Another way to solve quadratics is by completing a square. No matter what form you're given, as long as it's quadratic, there's a few steps you need to follow. First and foremost is you need to make the equation look like this. Ax squared plus bx, leave a space because we will be filling it in, is going to equal c. So you want your constant on the other side, your variables on one side. Now the only thing about this one is that your a has to always equal 1. So if it equals anything else, you would divide every single term by whatever a is. Then what happens is you're going to take half of b. So whatever the coefficient is of your b, you're going to take it by divide it by 2, and then you're going to square it. Whatever your result is, you're going to add it to both sides, and that's where that blank comes in over here. When you have that, you're going to drop down to your binomial, because it will become a perfect binomial, and you're going to square root both sides, and then you'll solve. Now, when completing the square, it works every single time because you can have rational, irrational, and complex solutions. So looking at our first example, we have x squared minus 6x minus 4 is going to equal negative 9. First and foremost, we need to add that 4 to both sides, because we have to make sure our constant is what it's equal to. So then we have our x squared minus 6x, leave that space, is going to equal a negative 5. So then we take our b, which is negative 6, and we're going to divide it by 2, which gives us a negative 3. Then we need to square it, so that gives us a positive 9. The result here is you're going to add to both sides. Now at this point, you're pretty much going to factor this by a perfect binomial. So you drop down the parentheses, you have your x. Now whatever you squared here is what you put inside here. And then this would be squared. So if you were to multiply this out, you would come back up to the x squared minus 6x plus 9. And this is going to equal negative 5 and 9 gives you a positive 4. So now we still need to solve for x, so we're going to take the square root of both sides. So then we have an x minus 3 is going to equal a plus and minus. Now the square root of 4 is going to be positive 2. Do not forget these plus and minuses. So now we're going to have our two equations. We're going to have an x minus 3 is going to equal a positive 2, and an x minus 3 equals a negative 2. So we have x is going to equal 5, and then x is going to equal 1. So here are two solutions to our quadratic. Now in our second example, we have an x squared plus 4x plus 11. Once again, we need to move our constant over to the other side of the equal sign. So we're going to subtract 11 from both sides. So we have an x squared plus 4x is going to equal negative 11. So we take our b, which is 4, divided by 2 gives me 2. And then you square it, which gives me 4. So you're going to add 4 to both sides. So then drop down your parentheses, your x. Now here we have a positive 2, so it'll be a positive 2 here. Squared is going to equal a negative 7. Take the square root of both sides. So we have an x plus 2 is going to equal a plus and minus radical negative 7. Now we need to solve for x, so we subtract 2 to both sides. Now technically we cannot combine this because you have this sort of radical over here. So it's going to be an x is going to equal a negative 2 plus and minus. Now since we have a radical in our answer, we always need to make sure, do I need to pull out an I, and can I reduce it? Well, since we had this negative here, we know we pull out an I. Now with the radical 7, we can't reduce it, so just leave it in as your radicand. And then here's your answer here.